Hello everyone, today is day 60 of solving a LeetCode problem every day, and today I'm going to be solving diameter of binary tree. So given the root of a binary tree, you return the length of the diameter of a tree. The diameter of a binary tree is the length of the longest path between any two nodes in the tree. This path may or may not pass through the root. The length of a path between two nodes is represented by the number of edges between them. So here our output is 3 because the path goes from 4 to 1, 3 or 5 to 1, 3. So I do want to note that within the solution right here, the path does go through the root, but it doesn't necessarily have to pass through the root. So the general way I'm going to solve this is by basically just calculating the diameter for each subtree. So for example, we're going to look at the diameter for 1, and we can see that that's 3 because we have 4, 2, 1, 3. But then we're also going to look at the diameter for 2, which is going to be 2 because we have 4, 2, 5. We do the same thing for 4, same thing for 5. And then we keep updating that max variable, and then we return that as the output. So this is where we're going to start. We're going to start by initializing that max variable. We're going to call it response. And then we're going to do a depth first search. So that's how we're going to be finding the diameter. So we're going to create a reference to that. Ooh, why is it? That doesn't seem right. Okay, response is 0. Then we're going to define our depth first search method. And then we want to create the reference. So we're using depth first search, and the reason why is because we want to find the height of the tree. So we don't want to do breadth first search because we want to go as deep as possible first. We don't necessarily care about like the direct children, but then we're gonna have our base case where if there's not root, if the root is null, we're going to return 0, since we're basically indicating that there is not another level to the tree there. And then we of course want to traverse our left subtree and our right subtree. And then we're going to set our response to be the max between either response or left plus right. And the reason why we're doing that is left and right is going to be the height of each subtree. So for example, at 1, left is going to be 2 because we have 4 and 2 here, and right is going to be 3. And then left plus right gives us the diameter because that's going to be 2 plus 1, which is 3. And then finally, we're going to return 1 plus max left right. So basically what we're doing here is, for example, we start at 1, we go to left, and that's going to be depth first search root.left, and we're here. But let's say that we had an extra node here. Let's say this node 5 had a left child node that was, for example, like 3. It doesn't really matter what it is, but let's say there was a left child on this 5, 3. The reason we're returning max between left and right is because we want to return to the root node what the max height is. So the left subtree of 2 is going to have a height of 1, and the right subtree is going to have a height of 2, since remember we added that extra node. So we want to return that height of 2 to this node 1. So we know that the max diameter is 3, or sorry, it would be 1, 2, it would be 4 because we're adding the extra node here. So the reason why we have this max left and right is because we essentially just want to return whatever the max height is. We don't want to return, just the minimum or, randomize it. We want to make sure we're returning the largest height. So then after this, we can just start our depth first search. So DFS, we start it at the root, and then we can just return our response. So I'm going to run this and then submit it. Cool. So the time complexity of this solution is going to be O of n. So it's going to be linear. And the reason why is that we're processing each node just once. And then our space complexity is going to be constant. So yeah. But I guess one thing to note is this solution is recursive. So we are going to be actually taking up space on the call stack. So that's just one thing to note. So yeah, that's my solution for the day.